energy increases across, so does nuclear charge. And don't forget about atomic radius. That just decreases when it goes across. And shielding stays constant. And make sure everything's the opposite when it goes down. Everyone got it? Okay guys, test tomorrow. Let's go.
So both Divya and I noticed that in the past we've been having a lot of questions on our FRQs on the different periodic trends, and a lot of us miss points because we don't properly compare the two elements or properly explain why these trends happen. So we thought that before finals it would be a good idea for us to give you guys a quick crash course on these different properties and why they happen. So first we're going to go over nuclear charge, and the definition of nuclear charge is the number of protons you have in the nucleus. And if you go back to the basics, we can see that the atomic number shows us the number of protons. So by just looking at the periodic table, it's easy to compare the nuclear charge and know the exact number of protons because we have the atomic number. And as this animation shows, the nuclear charge increases as you go down a group because, as you can see, the atomic number increases down a group, which means the number of protons increases, thus the nuclear charge increases. And nuclear charge also increases across the period from left to right because the atomic number increases. So next we're going to talk about atomic radius, which is an important concept that you need to understand before you understand some of the other trends. Atomic radius is defined as the typical distance from the center of the nucleus to the boundary of the surrounding cloud of electrons. So as you can see here in this animation, the trend for atomic radius is that it increases as you go down a group and decreases as you go across the period. So in order to explain this, we can think about the number of energy levels across the group and across the period. So as you're moving down a group, the number of energy levels increases, thus the distance from the nucleus increases, which increases the overall atomic radius. However, when you're going across the period, all the elements are in the same energy level as we learned in basic regular chemistry. And because they're in the same energy level, the increasing nuclear charge as you move across the period pulls the outer electrons closer. And because the strong positive force pulls the outer electrons closer, the overall size of the atom decreases, thus decreasing atomic radius as we move across the period. Ionization energy is a bit more complicated. It's defined as the amount of energy you need to remove the most loosely bound electron of an element. And as you can see here in this animation, ionization energy decreases as you go down a group and increases as you grow across the period. So in addition to knowing the trends for ionization energy, it's extremely important that we understand why these trends happen. So for the trend that shows that ionization energy increases across the period is because of the increasing nuclear charge. So we learned in regular chem that elements in the same period have the same number of energy levels, which makes them about the same distance away from the nucleus. However, since the nuclear charge is increasing as you go across, the pull on the loose electrons increases, which makes it harder to remove the loose electron, which increases the ionization energy. And as you go down the group, we just showed you that the ionization energy decreases, and this is because the number of orbitals starts increasing as you go down the group. And because of the number of orbitals are increasing, the electrons are further and further away from the nucleus, which means they're less subject to the proton's positive force, and thus it makes it easier to remove the electron. So finally, we'll be going over electronegativity, which is defined as the tendency of an element to attract electrons. And as you can see in this animation, the trend for electronegativity is that it increases across the period and decreases down the group. It's actually the same trend as ionization energy. And in fact, you can even think about why these trends happen in the same terms as you did for ionization energy. So as you're moving across the period, you're in the same energy level as we explained earlier. and thus the increasing nuclear charge has a bigger role in the element. So as the positive charge increases as you move right, it becomes easier to attract the electron, and thus the electronegativity is higher as you move to the right. However, as you're moving down, the number of energy levels increases, which means that the distance away from the nucleus also increases. And thus the electrons are less subject to the nucleus's positive force, and thus the electronegativity decreases.
Okay, so now that you know how periodic trends actually work, 3 easy rules that will help you remember the trends and apply them are the following. So the first rule is that trends starting with an E, and that's energy of ionization and electronegativity, they increase across and decrease down the table. The second rule is that atomic radius is the opposite of the E rule I just said, and it decreases across and increases down the table. And the third rule is that nuclear charge increases in both directions. So now that we know the reasoning behind the periodic trends and actually what the trends are, let's actually apply this knowledge through some practice problems. Okay, so our first question is, which atom has the larger atomic radius, sodium or bromine? And the definition for atomic radius is the typical distance from the center of the nucleus to the boundary of the surrounding cloud of electrons. And again, the trend that the atomic radius follows is opposite from the E rule, so that means that it'll increase when it goes down and decrease when it goes across. And as we can see here, that bromine is in a row that's lower than sodium, so that means it's going to have a higher atomic radius. Okay, so the second question we have is, which of the following has the smallest ionization energy? And again, the definition of ionization energy is the energy required to remove an electron. And by the rules, we know that energy of ionization, so it starts with an E, so it's going to increase across and decrease down. And as you guys can see here, each of the elements are highlighted, and we can see that the furthermost left element is lithium, so that's going to make it the smallest. Okay, so the next question is, list the following in terms of decreasing electronegativity. So the definition of electronegativity, again, is a measure of the tendency of an atom to attract a bonding pair of electrons. And again, this is an E rule, so it's going to increase across and decrease down. And as I have all the elements highlighted on the periodic table here, we can see that boron is the most electronegative because it's furthermost to the right. And then it's followed by magnesium, and then the least electronegative is the potassium. So yeah.
I know it means a lot to y'all to understand periodic trends, but better teach them once and for all. Periodic trends forever, man, ever, man, ever, man. Nuclear charge electronegativity, atomic radius, ionization energy. We ain't even playing to stop. Periodic trends forever, man, ever, man, ever. Last name charge, first name nuclear. It's the amount of protons you got in the nucleus. Go across the table, nuclear charge goes up more. Go down the table, nuclear charge goes up more. Don't forget to count the protons, no joke. Just think about all them protons, you'll know. atomic radius, distance from the nucleus, we know. It all be dependent on nuclear charge, we know. Pump up the charge, looks like closer electrons. Closer electrons, you see the small radius come up on. But going down the group, the more stuff that I got. Atomic radius is flying up, that's what I thought.
Yeah, ionization energy ain't no question, only it is simple and trendy. Goes down to decrease and across to increase. Down the group electrons be further so the IE be lower. Across the table, nuclear charge brings electrons closer. Electronegativity is where it's at to pull electrons. That's the fact. It increases across and decreases down. Put them electron on the right, they be more thirsty. But as you go down, they not really hungry. Yeah, man, that's electronegativity.
It means a lot to y'all to understand periodic trends. We're gonna teach them once and for all. Periodic trends forever, man, ever, man, ever, man. Nuclear charge, electronegativity, atomic radius, ionization energy. We ain't even playing to stop. Periodic trends forever, man, ever, man, ever.